Driving into an underwater tunnel triggers a specific psychological shift. The natural daylight vanishes, the acoustic hum of your tires changes against the concrete, and as the road angles downward, the atmosphere shifts. As you descend, you face the weight of the water column above. For every 10 meters you drop, the hydrostatic pressure increases by 1 atmosphere, putting thousands of pounds of force per square foot against the concrete casing. Major infrastructure projects like Japan's Seikon Tunnel or the Channel Tunnel sit hundreds of feet below the surface. At these depths, water is relentless, heavy, and under enough pressure to crush the very air you're currently breathing. Most travelers assume these tunnels are simply waterproof pipes, concrete straws buried in the seabed that keep the water out through sheer material strength. That assumption overlooks the nature of concrete. It is inherently porous, and these massive structures shift and flex with the microscopic daily movements of the Earth. Water inevitably breaches the perimeter, meaning survival requires a highly active, continuous mechanical defense, which is every drop, funneling it down to the mid-river sump, a cavernous concrete reservoir designed to hold tens of thousands of gallons. When float sensors detect the water reaching a critical level, banks of towering centrifugal pumps roar to life. These turbines suck the water out and blast it vertically through discharge pipes, pushing it back into the ocean against the extreme pressure above. This system is built for resilience. During a blackout, automatic transfer switches move the pumping infrastructure to dedicated diesel generators, operating independently for days. This pumping cycle happens 24 hours a day. If these active defenses stop for even a few hours, the tunnel dies. If you ignore the air, the tunnel will still fail from the inside out. Thousands of hot combustion engines run continuously, creating a dense chemical and thermal environment that concrete alone simply cannot withstand. Trapped heat and friction, mixed with engine exhaust, create a dense, toxic humidity. Mixed with carbon monoxide and road salt, the air becomes a corrosive fog that eats away at the structural rebar, causing the ceiling to deteriorate. On the shoreline, massive windowless concrete towers are built to house the solution. Inside these ventilation buildings are some of the largest industrial fans on Earth, capable of moving millions of cubic feet of air per minute. They use transverse ventilation. High-pressure fans pump fresh air up through flues at wheel level, while exhaust fans create a vacuum in the ceiling, pulling toxic fumes and moisture straight up and out of the traffic zone. The tunnel acts as a mechanical lung, completely replacing the entire internal atmosphere every few minutes to keep the walls dry and prevent the structural steel from rusting. Despite these systems, engineers must plan for total structural failure, scenarios where a ship drags an anchor across the casing or an earthquake creates a major physical breach. The primary defense is extreme compartmentalization. The Channel Tunnel uses 3 separate parallel tubes, 2 main rail lines, and a central service tunnel. If sensors detect an unmanageable rush of water, massive steel floodgates, built like bank vaults, slide across the compromised tube to isolate the flood and save the rest of the network. Passengers evacuate through pressurized hatches into the central service tunnel. This middle tube acts as a permanent safe zone, isolated from the transit lines. This service tunnel is kept at a higher atmospheric pressure. When an escape hatch opens, air blows forcefully outward, creating a physical barrier that pushes smoke and floodwater away from escaping passengers. This specific engineering strategy prioritizes systemic survival. By utilizing these automated seals and separate conduits, the tunnel is capable of sacrificing a compromised section to protect the entire transit network. While the public roadway remains brightly lit, an invisible logistics network operates in the dark, cramped spaces around the tubes. Maintenance crews and sensors monitor water levels and air quality 24 hours a day to keep the machine running. The tunnel is less a road and more a massive industrial factory. The only product it manufactures is a dry, breathable stretch of asphalt. The front stage experience of driving through a tunnel is designed to feel entirely passive. But beneath that quiet surface, violent mechanical forces are spinning in the dark just inches from your tires. You aren't just driving through a hole in the dirt. You are moving through a highly pressurized fortress, an invisible machine constantly fighting the ocean to buy you a clear path to the other side.